Hello everyone. In this video, I will discuss the sampling distribution of the sample proportion p hat. Suppose you are making a survey, and in your survey you want to ask the population whether they drink soda or not. And because that question, there's only two possible answers. It's either the respondent or the participant will say, yes, I drink soda, or the participant will say, no, I don't drink soda. And because of that, there's only two possible responses. Then the data that you can collect is considered to be from a binomial population. And if you are given enough time, enough money, and you can go around and ask all the people in the certain area, then you will be able to calculate the proportion of people that will drink soda. And we call that proportion P. And P is equal to X over the total population. So X will be the number of people that will say, yes, I drink soda. And then N is the total number of population. But in most cases, this is difficult to do because it requires a lot of time and a lot of money, and in some cases you will not be able to go to places where there's people that you need to ask. So what you will do is you will select some sample from the population. So suppose we have here sample number 1, and we ask number of people, say N1, and out of those N1 people you ask, do you drink soda? And X1 of those people will say, yes, I drink soda. So then you can calculate the P1 hat. This represents the proportion of people that drink soda from sample 1. Or you can also collect another sample, and we call this sample number 2. And the number of people that you will ask here will be the same number of people that you will ask from sample 1. So you have N2, which is equal to N1. And you ask the same question, do you drink soda? And X2 people will say, yes, I drink soda. And you can calculate the proportion of people that drink soda from sample number 2. And we'll call it P2 hat. And you can continue doing this. You can collect from sample number 3, and you will be able to get P3 hat, the proportion of people that drink soda from sample number 3. And then from sample number 4, you can calculate the P4 hat, the proportion of people that drink soda from sample number 4. Now remember that the sample size will be the same for each of these samples. So N1 will be equal to N2, will be equal to N3, and equal to N4, and it will be equal to all the samples that you can collect up to the last sample that you will collect. So from the last sample, we call it the sample K. So you can calculate the PK hat, the proportion of people that drink soda from sample K. And what we are interested in is the distribution of P1 hat, P2 hat, P3 hat, P4 hat, and up to the last sample PK hat. And the distribution of this P1 hat, P2 hat, P3 hat, P4 hat, up to the PK hat, we call it the sampling distribution of the sample proportion P hat. There are two properties of the sampling distribution of the sample proportion p hat. The first one is if a random sample of n observations is selected from a binomial population with parameter p, then the sampling distribution of the sample proportion p hat, which is equal to x over n, will have a mean of p, and a standard deviation of SE of p hat is equal to the square root of pq over n, where q is equal to 1 minus p. Now the second property is when the sample n is large, the sampling distribution of p hat can be approximated by a normal distribution. The approximation will be adequate if np is greater than 5 and nq is greater than 5. So what this means is that if NP is greater than 5 and NQ is greater than 5, then the distribution of P1 hat, P2 hat, P3 hat, up to the last P hat, the distribution will be approximately normal distribution. Now let's take a look at an example of the sampling distribution of the sample proportion P hat. Here is our first example. A random sample of n equals 75 were selected from a binomial population with p equals zero point 0.4. Is the sampling distribution of the sample proportion p hat approximately normal? If it is, what is the average proportion and standard deviation of the sampling distribution of the sample proportion p hat? Now, it is important to note that in this question, we are told that the random sample is coming from a binomial population. And that's a very important piece of information because every time we talk about sampling distribution of the sample proportion p hat, that is related to a binomial population. All right, now to answer this question whether the sampling distribution of the sample proportion p hat is approximately normal or not, we need to calculate our NP and NQ. From the given information, our P is zero point 0.4, so we can solve for Q, and our Q is equal to 1 minus P, so 1 minus zero point 0.4 will give us zero point 0.6, so Q is equal to zero point 0.6. Now we can calculate our NP, and NP is equal to 75 times zero point 0.4, and this gives us 30. And NQ is equal to 75 times zero point 0.6, and this gives us 45. And because both of these numbers, 30 and 45, both of them are greater than 5, so we can say that since NP is greater than 5 and NQ is greater than 5, then the sampling distribution of the sample proportion p hat is approximately normal. The mean of the sampling distribution of the sample proportion p hat is equal to p, which is 0 0.04. And the standard deviation of p hat is equal to the square root of pq over n. Our p is zero point 0.4, our q is zero point 0.6, so we multiply zero point 0.4 times zero point 0.6 divided by 75, and then we take the square root of the result, and that gives us 0.0566. So this number is the standard deviation of the sampling distribution of the sample proportion p hat. Let's try another example. Here's our example number 2. An advertiser claims that the average percentage of brown M&M candies in a package of milk chocolate M&Ms is 13%. Suppose you randomly select a package of chocolate M&Ms that contains 55 candies and determine the proportion of brown candies in the package. What is the approximate distribution of the sample proportion of brown M&Ms in a package that contains 55 candies? In this problem, there's no mention about binomial distribution. But what we know is that when we open a package of M&Ms and we're looking at the color of the candies, then the color is either brown or not because we're counting the number of brown candies and we're also counting the number of non-brown candies. So it's either brown or not. So it's a binomial distribution. Now, to answer this question, what is the approximate distribution of the sample proportion of brown M&Ms? We need to calculate the n times p and n times q. Now, in this problem, we are given that in every package, there's 55 candies, so our n is 55, and the percentage of brown candies inside each package is 13%, so p is equal to 0.13. So from here, we can calculate the q. Our q is equal to 1 minus p. So 1 minus 0.13, and this is equal to 0.87. So q is 0.87. So n times p is equal to 55 times 0.13, and this gives us 7.15. Our NQ is equal to 55 times 0.87, and this is equal to 47.85. Now, because both of these numbers are greater than 5, then we can say that the approximate distribution of the sample proportion of brown M&Ms is approximately normal because n times p is greater than 5 and n times q is also greater than 5. And we can also calculate the average of the p hats, and that would be equal to p 0.13, and the standard deviation of p hat, sometimes we call the standard deviation as the standard error of p hat, is equal to the square root of pq over n. So we multiply 0.13 times 0.87 divided by 55, and then we take the square root of the result, and this gives us 0.0453. So the standard error of p hat is 0.0453. Or we could say the standard deviation of the sampling distribution of the sample proportion p hat is equal to 0.0453. Alright, that's it for this video. Until next time, thank you for watching.